So this is a lecture to help understand waves and the equations, frequency, all that type of stuff. So on your handout, hopefully you put down all these key terms. You recognize that all these key terms are on there, except for energy, so please write that down. So we're going to cover wavelength, frequency, energy, speed of light, and Planck's constant as well. So the wavelength is the distance between identical points in the, so basically in a wavelength, something like this, like we said in class, a wavelength is crest to crest or trough to trough. And like we said, that changes based on the frequency or the energy of the wave. So it's symbolized by something called lambda. So the easy way to draw it out is kind of like an upside down Y. So here, that's it. The unit is meters, symbolized by lowercase m. Sometimes they do give you meters, the wavelength in nanometers. So you need to make sure you know how to convert that. So like I said, lambda, lowercase m, and lowercase l in Greek, and that's how you pronounce it. If you're a Star Wars fan, the Lambda shuttle is the name. That's what they call Darth Vader and the Emperor Palpatine's shuttle, because it's shaped like lambda. So frequency is how often a wave passes a certain point. So if something is frequent, that means it happens a lot. So at a certain point, if a wave passes a lot of times, that means it's considered a frequent, thing. So that's what the frequency is describing. It's symbolized by nu, and the way that I describe it, it's a fancy V, but still try to call it nu. The unit is inverse seconds or 1 over seconds, or also hertz. The symbol for hertz is capital H lowercase z. Even though there are 2 letters there, that is still considered the base unit. Energy, way to describe it, it's something that's transferred from one body to another. So like physical energy, or some kinetic energy, potential energy, stuff like that. It's symbolized by capital E, and the unit is joule, and the symbol for that is capital J. Speed of light is the speed at which light propagates through different materials. So this, air versus like water or something solid, different speed. It's symbolized by a lowercase c, and the value, if you will, is 3.00 times 10 to the 8 meters per second. Planck's constant, you don't really need to write down this definition per se, but it's just a constant that's used to kind of relate the energy of a photon and its frequency. A photon is just a thing of energy, a thing of light. It's symbolized by a lowercase h, and the value in unit is 6.626 times 10 to the negative 3 joules seconds. So that's not it's an asterisk, it's not a snowflake according to somebody in class who asked that. So it's joules times seconds. So in class, you play with slinkies, and from there you hopefully remember the relationships that occur in waves, which is important. That's what you're expected to learn how to do. So the relationship between wavelength and frequency. If a wave passes a lot of times, if it's highly frequent, there's a high frequency, the wavelength itself is shorter, so this is indirect. Energy and frequency, a lot of energy going to those waves, the waves pass more frequently, so it's direct. The relationship between energy and wavelength, a lot of energy, high energy, more high frequency, but the wavelength itself is shorter. This is inverse or indirect. So some things I expect to see when you're solving problems with formulas. You'll get 3 formulas in a bit, or you should see them. And I need you to identify your knowns and unknowns, write down your formula, and rearrange before you plug in numbers, because that will make it easier for you. And then your answer needs to have a box, correct sig figs, and the unit. So remember that, just so you know, we're going to be multiplying and dividing here. So the sig figs will be based on the problem, and it's going to be the number with the smallest number of sig figs. So here are the three equations. E equals Planck's constant. So energy equals Planck's constant times frequency. Energy equals Planck's constant times the speed of light divided by wavelength. And and the last one, so I'm going to number this 1, 2, 3. C, so the speed of light equals lambda times frequency. So it's the speed of light which equals the wavelength times the frequency. So a wave has a frequency of 540 hertz and is traveling at 340 meters per second. So it's a bit of a cheat. So I'm going to say that automatically I will tell you that your C is going to be 340 meters per second, even though it should be 3 times 10 to the 8 meters per second. A wave has a frequency. The symbol for frequency is nu. And what is its wavelength? That's what I'm trying to find. So of my different equations, 1, 2, and 3, the only one that has the frequency and wavelength like this is C equals lambda times nu. So to solve for wavelength, lambda, I got to divide both sides by the frequency. This cancels out, and I'm left with the speed of light, or the speed, divided by the frequency, which is going to equal the wavelength. So 340 meters per second divided by 540 hertz. Remember, that's actually 540 inverse seconds to find my wavelength. So I'm going to divide these two. So 340 divided by 540 will give me 0.6296 something something something. So to get my units, I have meters per second divided by actually 1 over seconds. But because I'm dividing fractions, I'm just going to multiply by the reciprocal, so my unit becomes meters. So the wavelength will be something 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 meters. But because I have only 2 sig figs here in each of those, that means my final answer can only have 2 sig figs. So 1, 2, I look back, 0.63 meters. So just so you know that I'm expecting you guys to know your sig fig rules, to know how to calculate with sig figs in mind, and all that type of stuff. Just for information. FYI, number of points per thing. So identifying your knowns and unknowns, that's going to be 2 points. Your formula, 2 points. Plugging in numbers, 2 points. Final answer, 4 points. So calculate the energy of a photon of radiation with the wavelength of 6.4 times 10 to the negative 7 meters. So I found this emulator that I'm using. So this is what you should be doing on your actual calculator itself. If you need help with it, please let me know. I'll also post another video to make sure you guys know how to input exponents to your calculator. So energy is what I'm looking for, capital E. The wavelength is what I'm given, 6.4 times 10 to the negative 7 meters. So of the 3 equations, the only one that has both of these things in it is capital E equals hc over lambda. And you're probably thinking, where does that hc come from? It's not in the question. Those are both constants that you'll be given when you have quizzes, tests, etc. So don't worry about that, but you know how to use it correctly. Excuse me. So E equals, so kind of just using what's on the calculator. So 6.626 times 10 to the negative 34 times 3.00 times 10 to the 8 divided by my my wavelength. So even though in the calculator I'm not putting parentheses, I'm doing this for a reason. Because if you don't put parentheses in the calculator and you type it out like this, the times 10 to the exponent, then you're going to have issues with your actual calculating. Because what it will multiply the numerator, and you don't put parentheses on the bottom, it will divide by 6.4, then multiply the whole thing by times 10 to the negative 7, which we don't want to do. So this equals, because I have the calculator in front of me. So then it's 3.10579, but there's only 2 sig figs. So I look at my coefficient. So it's 3.1 times 10 to the negative 19, and it's energy, so joules. That's my unit. So a helium laser emits a light with a wavelength of 633 nanometers. What is the frequency of light? So you'll notice in my calculation, I actually converted my wavelength, and remember that your wavelength needs to be in meters, not nanometers when you plug in your stuff. And I'll explain why in a little bit. So wavelength of 633 nanometers. So my wavelength is going to be 0.12345 zeros, which I'm just trying to double check I have that. Then 633 or 633 meters. What is the frequency? Again, if you look, you only have those two things in those two variables in the question. So the only equation that has both of those things together is the last one. So C equals lambda times nu. I'm going to solve for frequency, so I can divide both sides by the wavelength. So C, so 3 times 10 to the 8 divided by 0.1234563. That's going to equal my frequency. So I'm going to do this with units so I can show you what I'm talking about. So apologize. So meters per second, and the bottom is meters. This is going to be my frequency. So if I'm dividing meters divided by seconds times, it's meters over 1, right? But because I'm dividing, I'm going to multiply by the reciprocal. So this would become 1 over meters. My unit now is actually 1 over seconds, and the alternate version of 1 over seconds is hertz. And since we're dealing with frequency, I'm going to be in hertz. So I do my math and I look at my calculator. I got 4.73933. So remember, just so you know, when you see this E, capital E, that means times 10 to the exponent. So with 3 sig figs in mind, my answer will be 4.74. 4.74 times 10 to the 14. I cannot write right now. Hertz. So that's it for now. If you have any questions, please let me know. Thanks.